We're on 4.6, the fundamental theorem of algebra. This is video number 2. We are finding all the zeros of a polynomial function. So to do that, for number 3, we want to find all the zeros in this polynomial function. So we first need to think of what are all the possible zeros we could have by taking the plus minus p over q like we did in the last section, or taking our graphing calculator and typing in the equation. And once we enter it in, we graph the equation, see what it's going to look like, and we see that we have a 0. So I know I'm going to have a 0 here, which is when x is -2. And if you remember back when we talked about repeated solutions, if it hits that number and then doesn't cross it and comes back, that's actually a solution twice. So I have -2 twice, and then I have where it's crossing the x-axis here, and that's at 1. So here are 3 of my solutions, but according to my degree, I should have 5 solutions. So I need to find the other 5 solutions. So we're going to take those 3 solutions, and we're going to divide them out of our polynomial. So let's move some things over here. All right. So I'm going to first start with the first one. I'm going to divide out a -2. I need to write all of my coefficients. The coefficient of x to the 5th is 1, of x to the 4th is 3, of x to the 3rd is 9, x squared is 23. Then we should have x to the first power. Remember, you have to include all powers. 5, 4, 3, 2, 1 isn't here, and then 0. Since the 1 is not there, it's going to be a 0, and then -36. Okay? We bring down the 1. 1 times -2 is -2. 3 plus -2 is 1. 1 times -2 is -2. Add that to 9. 7 times -2 is -14. Add that to 23, and you get 9. 9 times -2 is -18. Add the 0, -18. Multiply that by -2, and you get a +36. They add to 0. So that means my remainder was 0, which shows that -2 was a solution. But now I have, where I started with x to the 5th, this now gives me x to the 4th is my first term. And I'm just kind of marking it over there because I'm going to use these numbers and divide again. So this was when I had x to the 5th. These were the coefficients. X to the 4th is the degree of these coefficients, the highest coefficient there. And now I'm going to divide again, but I'm going to take out the other -2. All right, so I bring down my 1 times -2. Add these together. I get -1 times -2. Add together times -2. Add these together times -2. Add these together. Now I have a remainder of 0 again. So we knew that was a solution. Now this is the coefficient now of x cubed. I'm just marking that so I remember for later. But now we need to divide out our last solution that we know for sure. So bring down your 1 right here. 1 times 1 is 1. Add them together. 0 times 1 is 0. Add together. 1 times 9 is 9. Add together, and you get a remainder of 0 again. Okay, so if x cubed was the last one, this means my highest power is now x squared. So that means this is the coefficient to x squared. This is the coefficient to x, and since it's 0, I'm not going to write it. and this is my constant. Okay, so if all of these were solutions to my polynomial here, this is also part of solving, and I still have equals to 0 because this is all I have left of my polynomial after I divide out those solutions. Because really that was taking out an x plus 2 and another x plus 2 and an x minus 1 out of those solutions, out of this polynomial. So that leaves me with x squared minus 9 equals 0. So we're going to solve that. So if x squared plus 9 equals 0, I'm going to subtract 9 to both sides. X squared equals negative 9. To solve for x, I must square root both sides. So I get x equals plus or minus the square root of negative 9. We can square root 9 and get 3, and to get rid of the negative inside, we get I. So I get x equals plus or minus, square root of 9 is 3. To get the negative out, we have I. So there's two more solutions. I have a positive 3i and a negative 3i. Well, put those with our original solutions. I have the solutions of negative 2 again, 1, and 3i and negative 3i. So we did find this, all 5 solutions, because this is repeated. But when I'm listing my solutions, I don't have to write the negative 2 twice. So there are your solutions to number 3. All right, now if we go to number 4, we want to find our solutions to x cubed plus 7x squared plus 16x plus 12. I'm going to enter it in our calculator. Oops. And we're going to graph it. All right, so I can see for sure that I have solutions here, and that's at negative 3. And it looks like I have a solution again at negative 2, but I can't tell exactly which one of those might be repeated. I do know I have to have 3 solutions because my degree is 3. So let's divide these out and see what our last solution is, just because I'm not sure which of those is repeated, because it looks like it could bounce off at either place. You could zoom in and see, but just to be on the safe side, I'm going to divide these out. So I'm going to first take out a negative 3. My coefficients are 1, 7, 16, and 12. Okay, I'm not missing any terms here. The degrees count down 3, 2, 1, 0. All right, bring down your 1. 1 times negative 3. Add those together. 4 times negative 3. Add these together. I'm sorry, 4 times negative 3 is negative 12. Add those together. 4 times negative 3 is negative 12 again. Add together. Your remainder is 0. Negative 3 was a 0 of it. And then let's divide out negative 2. Bring down your 1. 1 times negative 2 is negative 2. Add to 4. 2 times negative 2 is negative 4. Now you have a remainder of 0. All right, this is the constant. This has an x. So x plus 2 equals 0 is still left of our polynomial. After taking out, remember, if negative 3 is a solution, I divided out a x plus 3 out of my polynomial. And to take out a minus 2, I divided out an x plus 2. And now I'm left with another x plus 2. So if I set this equal to 0, I'm going to get that x is negative 2. So I actually had the solution of negative 2 twice. So my zeros to this polynomial are negative 3 and negative 2. Now go to your practice and do problems number 9, 12, 14, and 15.